Machine Learning Workshop, welcome everyone. So the agenda for today is just an introductory presentation. This is kind of non-technical. I'm going on the assumption that people know little to nothing about machine learning, except you've just come across it or heard about it. Then just take a break, trying to be less than 10 minutes, but just in case people are having issues, we'll just make sure that all the setup is working for everybody. Then we're going to do an introduction to machine learning workshop, which is just practical work for about an hour, where we're going to go into some of the machine learning algorithms that you commonly see, and we're going to kind of implement the simplest possible versions of these, so at least when you come across them in frameworks, you'll have some idea what they are. And then we'll take another quick break. Then we'll just do an introduction to TensorFlow. So TensorFlow is a very commonly, widely used machine learning framework built by Google. It's a really excellent one, and I kind of mentioned in the invite there's another one that people are using is one called PyTorch. But TensorFlow is a great one to get started, and plus TensorFlow works on Windows, whereas PyTorch doesn't. Alright, so just a quick introduction to me. Like most of you know me, but just to give, for those of you that don't, who am I and why am I doing this workshop? So I started working in EMC in December 2012. I was here till 2016, and then I went over to Sweden to work for Spotify for a while. When I was at Spotify, I got sent to a thing called Data University. So this was like an intense week-long course on big data in Spotify. We got to kind of build lots of data pipelines. We got to work on stuff like Discover Weekly and various, automatically generated content that users get, which machine learning is used a lot for. Then I was sent to OSCON, and when I was there, I met up with people from Google working at TensorFlow, and we did workshops there on TensorFlow and machine learning. It was really great stuff there, seeing stuff that's coming down the line, a lot of stuff about self-driving cars and that kind of thing. And when I came back, I did a bit of work on, primarily I was a back-end engineer, but I did some of the stuff on the ArcGIS page, lots of experimental features there that we had. And when I was there, I started running machine learning workshops in my tribe, because my tribe didn't have much machine learning expertise in it. And this workshop was kind of, based on that to some degree. And then I came back here in 2017. So what is machine learning? So the first thing I'm going to ask is what a machine is. And this is a definition of the Oxford Dictionary. You can think of a machine as like the obvious things, like a car or whatever, something that's driven by power. But you can think of a machine as software as well. You would have heard of the Turing machine, which is a machine that you can implement any algorithm. In machine learning, we build machines that can learn, and we can do that in software. What is learning? It's the acquisition of knowledge or skills through study, experience, or being taught. So we're bringing this definition of learning into the world of software. And this is one definition of machine learning. Machine learning is still quite a new field, so you'll get lots of different definitions of it. This is one that's kind of commonly used. It's the idea of improving a program without explicitly programming it to do what you're teaching it. There's different kinds of machine learning. Well, there's many, many different kinds of machine learning and aspects to it, but two that you'll come across most are supervised learning, which is the most successful branch of machine learning. But unsupervised learning is a very interesting branch of machine learning too. The difference there is supervised learning is you have data, you know something about it, you feed it to a machine and you come up with some other data. You get the machine to take in something and give you some other data back. Whereas unsupervised learning is you've got a load of data, you don't know much about it, and the machine starts to understand that data and cluster it in some way. Okay, so machine learning and AI. So artificial intelligence is a huge field. Machine learning is a subset of that. Machine learning is a separate field that intersects artificial intelligence, but is also outside of artificial intelligence. And deep learning, which is something we're going to look a little bit into, is a subset again of machine learning. And you can think of the outer machine learning layer being these kind of easy enough to understand things like decision trees, linear regression, whereas deep learning is neural networks and things that are a lot more difficult to understand. And actually a lot of deep learning systems out there, people actually don't really know how they work. They just apply, they do research, they trial and error, they build these machines that can learn and do stuff, but nobody really fully understands the internal mechanics of how they work. So it's a fascinating field. What can we use it for? Well, it's just some of the things we can use it for. We will make predictions. If you have some data, historical data, and if you can map it, correlate it to something happening on Monday, predicting something on Tuesday.
Has joined the conference.
Build up enough that you can make predictions, recognizing patterns, maybe clustering pixels, image recognition, extract some insights, something that might not be obvious to a person. A machine might tweak it. This is used a lot in medicine, for example. Discover anomalies, again. They use this in hospitals for checking, scans and stuff like that. Machine learning is applied there. Example of some of the simple prediction algorithms we'll look at. Regression problems, linear regression, logistic regression. And a very simple example of a linear regression is, say you have the house prices in an area, and then you could correlate that to the size and the feet of houses. And if your house is a certain size in feet, you might be able to predict how much money you're going to get for it. You can do the prediction by applying a simple linear function onto the data set, and basically you just put an X where you think, and that's a prediction of how much it's going to be worth. Logistic regression, like you might take a set of images, and you might say, like, is there a cat in this image or not? A logistic regression kind of gives you a true and false action based on some training data. Classification is another big thing in machine learning. That's like taking large amounts of data and grouping it in some way that's useful. And you'll often use these machine learning things together in some way. Naive Bayes is something you'll hear mentioned a lot in machine learning anytime you read about it. Basically, like the Naive Bayes algorithm, and the simple way to think about it is it's just a really clever way of drawing a line between data sets. So like if you imagine you have like email spam, and you have like a ton of emails that are definitely spam, and you have a ton of emails that are definitely not spam, and then you have like a bunch in the middle that may or may not be. Naive Bayes is now good and allows you to put a line through that, so that you have the minimum amount of error between getting things wrong with that in that categorization. Checking what genre is a song, is the face of the owner of this phone. It's used in face recognition. And then deep learning. Which I mentioned earlier, there's this data set out there that we'll look at a little bit. It's the MNIST is a handwriting database, so it's all kind of handwritten characters that you can use to identify handwriting. Medical vision, I mentioned that a little bit. There was a study done a while back using deep learning where they took all the medical scans, I think it was lung scans or something like that had been the historical cases, or say ones they knew that was some kind of a tumor or something, and ones that weren't. And they fed these into a machine, and then they trained the machine on it, and they got the machine to predict how many of these things were anomalies, and they compared it to humans. So they gave human doctors the very same sets, and the machine beat them every time, like by a huge amount. Credit scores, so it can take tons of data from tons of different places and predict how trustworthy you are, which is something that's been used a lot now. And machine learning, in its simplest form, boils down to what we know, some system that you build that you want to ask questions of, and what you want to know. And I'll come back to that last slide in a minute, but so I'm just going to tell some machine learning stories and set the scene a little bit and try to get you all super enthusiastic about how amazing this stuff is. So the first one is about this guy called David Cope, and this is actually a video. Let's see how this works. I'm hoping we get audio coming out of somewhere. Well, this is a song and a video in the style of, the song is in the style of Vivaldi. And of course the song was written by a machine, and all the music in it. And this guy, David Copes, he was a music composer, but he started playing around with machine learning and artificial intelligence way back when, like back in the 70s or something. And he's been working on it for many years, but he learned that you could take all the historical music of an artist and train a machine to write music just like that artist. He discovered a lot of weird things about it, like the music wasn't great just by teaching it, so if you added some randomness into it, it would generate music that sounded more like a human wrote it. Then he came up with an algorithm that was able to identify good music, so like the artificial intelligence would generate thousands of songs, and then he would cluster those songs on quality using another algorithm. Both of these were taught machines, and he was able to go, like, he himself was a composer, and he was able to show these songs at events, and like people weren't able to tell the difference between whether this was a real composer or a machine. So I just think it's a really cool story and a really cool example of machine learning that was done by one person on their own. Machine learning in finance. So has anyone here heard of Renaissance Technologies? If you read that book, Fire and Fury, by Jones, one of the heads of that company is in it, Mercer. But just kind of roughly the backstory of this crowd is they're computer science people, data analysts. One of them was a code breaker back in the Cold War. They started up a really interesting story of how it started, but fundamentally what it was taking the whole thing of finance, the stock market in New York and all that, and applying algorithms and machine learning to it instead of like taking the human element out of it essentially, and it gave them a massive advantage. Like you can see here, from 2001 to 2013, this particular fund, it's one fund of a few in that company, their worst year was a 21% gain. In 2008, they jumped almost 100% in value. All this is like predictive technologies, learning how the stock market is performing and applying what it's learned to make predictions. So, and I think that company, compared to other exchange companies, they have way less staff. Like nearly a third of their staff are PhDs in various kind of sciences, data science, stuff like that. So it gives them a massive advantage over people that aren't using machine learning for this. Mattersight is another interesting company. Calls may be recorded for quality purposes. When you hear that on a call, it's not for people to listen to, it's for machines to listen to in general. The machines will record and process the data that's your calls. And they're using that to teach machines to learn as much as they can about you and basically categorize you when you come in. It's a classification machine learning problem. And they'll match you up with representatives who will suit you best based on your personality and what they can figure out about you in that time. And they're having a lot of success and making a lot of money with this, saving companies tons of money. IBM are taking it kind of to the next level and making support calls completely AI and trying to take humans out of that side of it altogether. Alright.
We'll be known that before we can all retire.
Yeah, they're taking over. But basically, the best way to think about like how does machine learning relate to us is, do you have a question that you think machine learning could answer? Is there some task that you're doing all the time that you could teach a machine to do, and it doesn't seem reasonable just to write a script to do it? Is there some prediction you'd like to make regularly, often, and would you like to keep getting better? Is there a data set that you have to process regularly or gather some insights out of it regularly in a manual fashion, like SQL, whatever? Will it rain tomorrow? How will the stock market perform on Tuesday? Can I make this robot jump over this thing? These are all things that you can use machine learning for. Once you have a question, do you have the data to answer it? And this is like obviously fundamental. And if you don't have the data right now, can you get it? Data is the new oil is a quote you hear a lot. It really is. You just got to gather as much of it as you can, hold on to it, keep it, and then use it and profit. So yeah, if you've got a question on data, machine learning is the way to go. And like in any domain, you know, if you've got competitors, whichever competitor successfully uses machine learning first will win. You know, it's always been the case. Every example that you looked at there, these people are crushing the competition just by using machine learning. And if you can get some advantage and get in there first, it'll suck for everyone else, but it'll be great for you. So it's something that's definitely worth looking at. That's the end of the introductory talk.